Hello students, today we are going to start the Directrix and focus method for ellipse, parabola and hyperbola. So before starting drawing of this ellipse, parabola, hyperbola with Directrix and focus method, let us discuss about Directrix and focus. So what is Directrix? So Directrix is the fixed straight line. So here is the Directrix and focus is a fixed point. So F is a focus and it is a fixed point. So focus will be on the conic axis. Now what is conic axis? It is a line which is perpendicular to the directrix, and we can also say that the conic axis are the axis of the curves or axis of the conic. Now before starting drawing, it is necessary to understand a term known as eccentricity ratio. So to understand the definition of the eccentricity ratio, let us take a moving point like this. So this will be the moving point and it will trace any of the curve from ellipse, parabola, hyperbola. So we can say that what is eccentricity ratio? It is the ratio of distance of moving point from focus to directrix. If we will mark any point on this curve, let us say this point is a moving point, point P. So it is the ratio of eccentricity ratio of distance of moving point from focus to moving point to directrix. So it is the ratio of distance of moving point from focus to directrix. Now if this moving point when this moving point intersect the conic axis, the point of intersection of this curve and the conic axis is known as the vertex point. So we can also define the definition of the, or we can also discuss the definition of the eccentricity ratio like this. It is the ratio of distance of vertex from focus to directrix. So it is the ratio of distance of vertex point from focus to directrix. So eccentricity ratio is equal to Fv upon Vd. Fv distance of vertex from focus, Vd distance of vertex from directrix. Now if this eccentricity ratio is greater than 1, the curve generated will be hyperbola, and we can say that when eccentricity ratio is greater than 1, the distance of focus to vertex is greater than the distance of vertex to directrix. If the eccentricity ratio is less than 1, the curve will be ellipse. So we can say that the distance of vertex to focus is less than the distance of vertex to directrix. When eccentricity ratio is equal to 1, the curve will be parabola. So we can say that the distance of focus to vertex is equal to the distance of vertex to directrix. And if the eccentricity ratio is equal to 0, the curve will be circle. At that time we have to take the vertex point on the focus. So now let us discuss the definition of ellipse, parabola and hyperbola in terms of the directrix and the focus. So ellipse is the locus of point moving in a plane such that the ratio of distance of moving point from focus to directrix is constant and less than 1. Now the definition of the parabola and hyperbola. So in each and every definition the statement will remain same, only the change is here the ratio will remain constant and equal to 1, and here the ratio will remain constant and greater than 1. Now let us start with this example. Draw an ellipse with directrix and focus method having eccentricity ratio E is equal to 2/3 and distance of focus from directrix is 50 mm. Also draw normal and tangent to the curve at any point. So the distance of focus from the directrix is 50 and eccentricity ratio is 2/3. So here will be the directrix this will be the conic axis, perpendicular. The distance of focus, this will be the focus point. So distance of focus from the directrix is 50 mm. So this will be the directrix D. So DF is equal to 50 mm. So mark the focus point at a distance of 50 mm from the directrix. Now after marking the focus point, we have to mark the vertex point. So to mark the vertex point, do the summation of this ratio, 2 plus 3, it is equal to 5. Now divide this distance, D to F distance, into 5 equal parts. Divide this distance into 5 equal parts. This distance into 5 equal parts. 5 equal parts, 1, 2, 3, 4, 5. You can use the inclined line method to divide this distance. Now E is equal to 2 by 3. So VF upon VD, or FV upon VD. So FV is 2 units, 1, 2. So the distance of focus to vertex is 2 units. So count 1 and 2. So this will be the position of the vertex point, and the distance of focus to vertex will be equal to 20 mm, and vertex to directrix will be equal to 30 mm. So now in directrix and focus method, after marking the vertex point, the next step is draw a line perpendicular to the conic axis from the vertex point. So we have to draw this line which should be perpendicular to the conic axis from vertex point. So after drawing this line, now the next step is measure V to F distance on the rounder and give an arc on that particular line and mark this point and give the name of this point. Let us say that the name of this point is point J. Now connect this point J to D and draw this line. Connect this point D to J or DJ line and extend this line. Now if we will measure this angle alpha will be less than 45 degree. After connecting this line D to J, draw a line inclined at an angle of 45 degree from the focus point. 45 degree from the focus point. So draw this line which should be inclined at an angle of 45 degree from the vertex point, and mark the intersection point of this line and this line. Thus this line will intersect this line at this point. Give the name of this point as H. After marking this point, draw a line from this point and perpendicular to the conic axis. So we have to draw a line from H which should be perpendicular to the conic axis and mark this point as a vertex point V2. So we can say that this point is a vertex point V1 and this point is a focus point F1. So after deriving V2 point, divide this distance V1 and V2, or make divisions in between V1 and V2. You can make the divisions randomly or you can mark the points randomly. And one important thing is take one point on the focus point. Take one point on the focus point. So divide this distance V1 to V2 or make divisions in between V1 to V2. You can make random divisions like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So after taking divisions, draw lines perpendicular to the conic axis from these divisions. Perpendicular to the conic axis from these divisions, like this. extend the lines passing from these divisions up to this line. Make sure that this line should be perpendicular to the conic axis or parallel to the directrix. Now give the name of the intersection points of these lines and the line DJ: 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash and 9 dash. 1 2 3 4 5 6 up to 9, 1 dash up to 9 dash. So after taking these divisions, what is the next step? Now measure 1 to 1 dash on the rounder and give an arc from the focus point on the line 1 1 dash. Then measure 2 2 dash, give an arc from the focus point on the line 2 2 dash. Measure the distance of 3 to 3 dash and give an arc from the focus point on the line 3 3 dash. Measure the distance of 4 to 4 dash on the rounder, give an arc from the focus point on the line 4 4 dash. Measure the distance of 5 to 5 dash on the rounder, give an arc from the focus point on the line 5 5 dash. Same, measure the distance of 6 to 6 dash on the rounder, give an arc from the focus point on the line 6 6 dash. 7 to 7 dash, give an arc from the focus point on the line 7 to 7 dash. 8 to 8 dash, give an arc from the focus point on the line 8 8 dash. 9 to 9 dash, give an arc from the focus point on the line 9 9 dash. And V2 to H, give an arc from the focus point, it will intersect at V2, exactly it will intersect at V2. Now mark these points, give the name of these points and draw the freehand curve passing through these points, will give us an ellipse. So mark the point like this and draw the freehand curve passing through these points. The curve generated will be an ellipse. Draw the freehand curve passing through these points. The curve generated will be an ellipse. So this curve will be an ellipse. Now here it is also given that also draw normal and tangent to the curve at any point on the curve. Now we have to mark any point S on the curve. Let us say that this point is the point S from which we have to draw the normal and tangent. In Directrix and focus method, the method to draw normal and tangent will be different, but in the further methods or the method that we have discussed, the arc of the circle method, concentric circle method and oblong method, in each and every method the method will remain same to draw the normal and tangent, but here the method is little different. So now after marking point S, join this point S to the focus point and draw a line perpendicular to this line SF from the focus point in the direction of the directrix. And mark the point of intersection of this line to directrix as S1. Join this S to S1 or S or S1. The line will be the tangent and draw a line perpendicular to the tangent from the point S. Perpendicular to the tangent from point S will be the normal. So this line will be the tangent, this will be the normal to the curve. So this is all about the directrix and focus method to draw an ellipse. Thank you.